The James Webb Space Telescope, JWST, stands as the world's premier observatory for space science, ushering in a new era of cosmic discovery. Its mission? To unravel the mysteries of our solar system, distant exoplanets orbiting other stars, and the vast structures of the universe, all while helping us better understand our place within it. In a remarkable scientific breakthrough, astronomers recently aimed the JWST at a star located 120 light-years from Earth. What they discovered has captivated the astronomical community, compelling evidence of carbon-based molecules in the atmosphere of a possible ocean world, a planet dramatically different from anything found in our own solar system. This extraordinary find raises profound questions about the existence of habitable environments beyond Earth. Let's dive into the details of this groundbreaking discovery. At the heart of this revelation is the exoplanet K2-18b, a super-Earth approximately 8.6 times the mass of our planet. What makes K2-18b so intriguing is the detection of carbon-containing compounds, specifically methane and carbon dioxide, in an atmosphere, pointing to the possibility of life-supporting conditions. The planet also appears to have a hydrogen-rich atmosphere and potentially a surface covered by deep oceans. K2-18b orbits a cool red dwarf star, K2-18, located in the constellation Leo, within the star's habitable zone, where temperatures could allow for liquid water. The initial atmospheric analysis of this exoplanet was performed using NASA's Hubble Space Telescope, which laid the foundation for the JWST's deeper exploration. Planets like K2-18b, which fall between Earth and Neptune in size, are rare within our own solar system, but may be common throughout the galaxy. This makes them valuable targets in the search for alien life. Adding to the excitement, there are early hints of a molecule called dimethyl sulfide DMS in K2-18b's atmosphere, a compound produced on Earth almost exclusively by marine plankton. While this evidence is still tentative and requires further confirmation, the potential implications are enormous. More detailed JWST observations in the near future aim to verify its presence. However, scientists urge caution. While K2-18b resides in a habitable zone and contains promising chemical signatures, that doesn't necessarily mean it supports life. Its radius, 2.6 times that of Earth, suggests it might have a dense, high-pressure ice mantle, similar to Neptune, overlaid by a thinner hydrogen atmosphere. And though oceans may be present, they could be too deep, pressurized, or chemically unbalanced to sustain life as we know it. Still, researchers have managed to capture the most detailed atmospheric spectrum of any habitable zone sub-Neptune planet to date, giving us unprecedented insight into the molecular makeup of this distant world. As one astronomer from the University of Cambridge emphasized, K2-18b may not yet prove the existence of life, but it brings us a step closer to finding planets that could. The university team explained that they overcame this challenge by analyzing the light from K2-18b's host star as it filtered through the planet's atmosphere. K2-18b is a transiting exoplanet, meaning its brightness dips when it passes in front of its star, a phenomenon that led to its initial discovery by NASA's K2 mission. During these transits, some of the star's light travels through the planet's atmosphere before reaching space-based telescopes like the James Webb Space Telescope, JWST. This filtered light carries subtle signals, spectral fingerprints of atmospheric gases, that astronomers can study to determine the planet's composition. The team plans to conduct further research using JWST's mid-infrared spectrometer to confirm their current findings and gain deeper insights into K2-18b's climate. Ultimately, their goal is to search for signs of life on potentially habitable exoplanets, a discovery that could transform our understanding of life in the universe. But that's not all. The JWST has also made other astonishing discoveries. Astronomers have detected complex organic molecules, similar to smog or smoke, in a distant galaxy. This is the earliest known detection of such molecules in the universe. Personally, I find it both inspiring and humbling. These discoveries, made in the most remote regions of space, are challenging the very foundations of cosmology. These molecules, known as aromatic hydrocarbons, are carbon-based compounds also found on Earth in substances like petroleum, coal, and air pollution. What makes this discovery so remarkable is the timing. They were detected in a galaxy that formed when the universe was only about 10% of its current age. These large, complex molecules, made of dozens or even hundreds of atoms, were not expected to form so quickly after the Big Bang. Yet the light we're observing from this early galaxy began its journey less than 1.5 billion years after the universe's origin. Remarkable, considering the universe is now about 13.8 billion years old. We are witnessing some of the earliest stages of the universe's evolution. What's even more impressive is that this discovery was made possible by the Webb telescope, which is expected to continue enabling groundbreaking observations for nearly another billion years. This raises a profound question. If we could look even further back in time, might we find even more of these complex molecules, perhaps closer to the moment of creation itself? Until now, earlier attempts to detect such molecules in ancient galaxies could only confirm their existence. But thanks to JWST's unprecedented resolution, we can now map where these molecules are located in detail. Interestingly, the distribution of these molecules within the early galaxy SP 4-1847 appears uneven, an unsolved mystery in itself. Even more astonishing is that this galaxy was already as massive as our Milky Way, and its stars had already produced significant amount of carbon and oxygen, despite the galaxy being only a tenth the age of ours. As we continue to explore the cosmos with tools like JWST, we're reminded of the vastness and complexity of the universe. With every scientific breakthrough, we take another step closer to unlocking the secrets of the stars. As our cosmic exploration advances, it's only a matter of time before the universe reveals even more. If you found this journey through the cosmos fascinating, don't forget to subscribe and hit the notification bell. The James Webb Space Telescope is redefining what we know about exoplanets and distant galaxies, peering deeper into space than ever before and uncovering mysteries that were once beyond our reach. The discovery of complex organic molecules in far-off galaxies is a striking example of how the James Webb Space Telescope JWST is revolutionizing our understanding of the universe, particularly its early stages and ongoing evolution. Among the most compelling aspects of these findings is the suggestion that life, or at least the fundamental ingredients for life, may exist in environments once believed to be uninhabitable. For instance, the detection of carbon-based compounds like methane and carbon dioxide in the atmospheres of exoplanets, such as K2-18b, has opened exciting new pathways for identifying potential biosignatures on planets that may bear similarities to Earth. While such molecules are often linked to biological activity here on our planet, their presence elsewhere does not necessarily confirm life. Rather, it encourages further study into conditions that could make life possible beyond Earth. JWST's extraordinary capability to analyze exoplanetary atmospheres with high precision marks a significant technological leap. It allows scientists not only to identify basic elements, but also to detect more complex organic molecules, key indicators that could suggest biological processes. This level of detail is essential for evaluating the habitability of distant worlds. As our knowledge expands, so does our ability to recognize subtle signs of life, whether in the form of specific gases, organic compounds, or other markers of possible biological activity. Beyond exoplanet studies, JWST is also delivering profound insights into the formation and evolution of galaxies. By observing galaxies that are billions of light years away, astronomers can trace patterns of star formation, the distribution of chemical elements, and the mechanisms behind galactic growth. These observations are vital to piecing together the history of our own galaxy, the Milky Way, and understanding how it came to be. One notable breakthrough is the discovery of aromatic hydrocarbons in a galaxy that formed relatively early in the universe's history, offering a glimpse into the chemical complexity of the early cosmos. Such discoveries highlight how much progress we are making in unraveling the universe's mysteries. With every new observation, we inch closer to answering some of humanity's most profound questions. Are we alone in the universe? What are the essential conditions for life to emerge? How did the universe evolve, and what might its future hold? The James Webb Space Telescope is more than just an astronomical instrument. It's a gateway to the distant past and a guide to the future of space exploration. In the coming years, it is poised to deliver even more groundbreaking revelations. From studying the earliest epochs of the cosmos to uncovering new worlds and analyzing their atmospheres for signs of life, JWST is redefining what we know about the universe. Each discovery reminds us how much there is still to learn. The JWST, with its unmatched capabilities, stands at the forefront of this journey, not just as a scientific tool, but as a symbol of humanity's enduring curiosity and desire to understand the cosmos. As it continues to scan the skies, the potential for astonishing breakthroughs is limitless. Whether it's revealing new exoplanets, exploring ancient galaxies, or possibly detecting life in the unlikeliest of places, the James Webb Space Telescope is shaping the future of astronomy and expanding the boundaries of human knowledge for generations to come.